Yes, Smita, now you can start.
ওকে সো জলি ম্যাম আর শ্যামশ্রী ম্যাম, আমি আগে মার্কস গুলো ডিসক্লোজ করে দিচ্ছি, তারপরে আই শেয়ার দ্য স্ক্রিন অ্যান্ড শো দ্য কারেক্ট আনসার্স ফর অল দ্য কোয়েশ্চেন্স. ওকে, so Praveen has got a total of 44 out of 50. Rupsha has got 33 out of 50. Jolly ma'am has got 43.5 out of 50, which is a roundabout of 44. Shoma ma'am has scored 47. Rima ma'am has scored 24. Indrajit has scored 26. And Shamusri ma'am has scored 38. Evar, I will be sharing my screen and I'll showcase. Please let me know if the screen is visible.
Yeah, now it is okay.
Okay.
Yes, ma'am.
So for the short answer type questions, I have highlighted in bullet form what are the type of answers or phrases that I am looking for in each of the answers. So the first question was differentiate between cross-sectional and longitudinal research designs, highlighting their strengths and limitations. What I have noticed in the paper was that while many people have differentiated between cross-sectional and longitudinal research design, they have not touched upon the strengths and limitations. Okay, so over here, the entire answer is given. So it talks about the cross-sectional research design involves collecting data from different groups at a single point in time, whereas longitudinal research design involves studying the same individuals repeatedly over an extended period. So each of the research designer's strengths and limitations have also been highlighted. Cross-sectional research design strengths are time efficient, cost efficient, no attrition issues are seen, and it's also useful for generating hypotheses, whereas limitations cannot study developmental change directly, and cohort effects may confound the findings. And for longitudinal research design, the strengths include allows examination of change and development over time and also reduces cohort effects, whereas the limitations include that it is time consuming and expensive. Also, attrition and practice effects may threaten the validity of the research design. I hope this is clear.
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay. Moving on to the next short answer question, that is explain the block design and discuss how it helps in controlling extraneous variables in experimental research. Again, in most of the answers, the common issue with this particular question was that how extraneous variable, everything has been described properly. What is a block design? What is extraneous variables? Experimental research, what is the use of extraneous variables? Everything. But the few key areas in ways of controlling or how controlling extraneous variables helps, that has not been touched upon by most of the people. So over here, I have highlighted all of them. The answer basically is the block design is an experimental design in which participants are grouped into blocks based on the extraneous variable that may influence the dependent variable. Random assignment to experimental conditions is then carried out within each block. Either it was not mentioned that the participants were grouped based on a extraneous variable or a common characteristics, and another miss out that was most common in this answer. Control of extraneous variables is basically we do by ensuring equal distribution of the blocking variable across conditions, reduces error variance, and also increases internal validity and statistical power. Therefore, block design enhances experimental precision by systematically controlling known extraneous variables rather than leaving them to the chance. Is this understandable?
Yes, ma'am. Understood.
Okay. Welcome, Shoma ma'am. I am just discussing the answers
Yes.
of all the short answer questions. Please let me know if you have any issue in understanding any of them. Okay.
Okay, ma'am. Okay, okay.
So number 3, we have the question, distinguish between structured and unstructured interviews with reference to flexibility, depth of data, and researcher bias. I think Shamustri ma'am had answered this question very well. But again, the most common thing that I had noticed was that while everyone is describing what is a structured interview, what is an unstructured interview, the points that have been required by the question, flexibility, depth of data, researcher bias, were either touched upon very lightly or were not touched upon. In the sense, if somebody is writing the answer on flexibility and depth of data, researcher bias was not touched upon. Okay. So as a holistic answer, we can say that a structured interview uses a fixed set of predetermined questions asked in the same order for the participants, wherein the flexibility is low, depth of data is limited but standardized, since we are asking the same set of questions. Researcher bias is minimal due to the uniformity of the procedure that is being maintained. However, in an unstructured interview is open-ended with no fixed format, allowing the allowing the interviewer to explore responses freely. Therefore, flexibility is high, depth of data is rich and detailed, and the chances of researcher bias are higher due to the non-uniform format of this particular style of interview. Okay, understandable?
Yes, ma'am.
Okay. Moving on, we have explained grounded theory and discuss its significance in qualitative psychological research. So, this answer, motamoti, everybody got correct. Grounded theory is a qualitative research method aimed at developing theory inductively from data rather than testing existing theories. Data collection and analysis occur simultaneously through coding, constant comparison, category development. If you remember, Shumana ma'am talked about memos and thematic analysis coding in grounded theory. So that is what this question is asking you about. So the significance is that it generates a theory grounded in participants' lived experiences. It is useful in exploring under-researched or complex psychological phenomena and also enhances the conceptual depth and the explanatory power of the theory. So grounded theory is particularly valuable when existing theoretical frameworks are inadequate or absent, and therefore new theory needs to be developed that is grounded in data, as in that is based upon the empirical evidences that is being found. Okay, is this understandable?
Yes, ma'am.
Okay. Next, we have the last short answer type question, that is differentiate between stratified random sampling and cluster sampling, stating the situations in which each is most appropriate. Again, the most common mistake while you are differentiating between stratified random sampling and cluster sampling, the situations as examples are not being provided. Okay. So here, stratified random sampling basically involves dividing the population into homogeneous strata, that is by gender or socioeconomic background, and randomly sampling for each stratum. It is a type of probability sampling which ensures representation of key subgroups and appropriate when subgroup comparison is important. Whereas cluster sampling is basically dividing the population into natural groups, naturally occurring clusters, such as schools, community, and then randomly selecting within the entire clusters. Both of them are cost effective and practical, appropriate when population is geographically dispersed or sampling frame of individuals is unavailable. So stratified sampling improves precision, whereas cluster sampling improves feasibility. Over here, the situations basically what I was looking for is that dividing the population in homogeneous strata, especially when the population is actually heterogeneous and you have to make it as homogeneous as possible. And for cluster sampling is basically dividing the populations in naturally occurring cluster groups. Is this clear?
Yes, ma'am.
Okay. I will be showing the MCQs right now. I don't think much explanation of the MCQs answers are required. If you have any doubt, please let me know. But for now, I'll just show the answers and the correct option of them. The highlighted ones are the correct option, okay? And please let me know when I should scroll. Please let me know. Scroll যখন করতে হবে।
Done.
Jolly ma'am, can I scroll?
শোনা যায়নি।
ম্যাম এই মাঝখানে কিছু শোনা যায়নি, সাউন্ডটা অফ ছিল।
হ্যাঁ, আমি কিছু বলছিলাম না, আমি জিজ্ঞাসা করলাম যে তোমাদের পড়া হয়ে গেছে কিনা, তাহলে আমি স্ক্রোল করতে পারবো কিনা।
হ্যাঁ 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 ম্যাম।
ওকে ওকে। এটাও হয়ে গেলে প্লিজ বলো।
Done.
জলি ম্যাম ডান?
ইয়েস ম্যাম।
Okay. Please go through question number 7, 8, and 9. হয়ে গেলে প্লিজ জানিও।
হ্যাঁ ম্যাম হয়ে গেছে।
ওকে। কোয়েশ্চেন 10 আর 11টা দেখে নাও।
Done.
হ্যাঁ ম্যাম
জলিনা
হয়ে গেছে। হ্যাঁ ম্যাম হয়ে গেছে।
12 থেকে 14 দেখে নাও।
ম্যাম হয়ে গেছে।
তোমার ম্যাম?
Yes, done.
ওকে, এই ট্রান্সক্রিপ্টস আর কোয়েশ্চেনটা একবার দেখে নাও, তারপর আমি নিচে একেবারে শুরু করছি।
হয়ে গেছে ম্যাম।
তোমার ম্যাম আই হোপ হয়ে
হ্যাঁ
গেছে।
হ্যাঁ, that okay, okay.
ওকে ওকে, এই যে 16, 17, 18 is here.
হ্যাঁ ম্যাম 18 অব্দি হয়ে গেছে।
ওকে, সোমা ম্যাম?
Just a minute.
ওকে ম্যাম।
Done. Done.
ওকে, then we have 19 and 20th.
Done.
জলি ম্যাম?
হ্যাঁ ম্যাম হয়ে গেছে।
Okay, I think with that we have completed the MCQ and the entire question paper. কোনো রকম doubt or any questions regarding the question paper?
নো ম্যাম।
Okay.
No ma'am, it's okay.
All right, all right. Requesting everyone who has joined right now to please kindly go through the YouTube link that will be provided. The marks of the second evaluation has been announced at the very beginning. Requesting you all to please go through the link and the answers for the evaluation. I think Sneha ma'am has already joined, so we can begin with the class. So,
Students, do you have any question about your specific answer, or you have understood?
No
That
sir,
is
it's okay, understood.
okay. 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 Then thank you, Usmita,
thank you, sir.
for very nice presentation of
Thank
the
you, sir.
yeah. So this thing is very good. And if they have any question, they will talk to you later on regarding their
Absolutely, sir.
marks. Okay.
Absolutely,
Because now
absolutely.
they have understood the correct answer. So I think there will be no problem. And I am requesting all of you, please you present, because in your certificate you will write down. So therefore, that will be very bad if you are not present. Okay, Sneha, now you can start. Usmita, you make Sneha as the host.
Yes, sir. Done, sir. Sneha ma'am, you're the host now.
Okay, so I'm presenting the screen. Is my screen visible?
Yeah, it is visible now.
So in previous class, I have covered the regression, chi-square test, and the Spearman-Rank correlation. So anyone have any doubt regarding those topics? Hello, am I audible?
You are audible.
Okay, okay.
Okay, maybe they
So,
have understood for that reason they are silent.
okay, okay, assuming that all of you have understood. So I'm considering this slide and I will be starting with Man-Whitney-U test. So this is a non-parametric test. Okay. So I have already taught the parametric test for t-test only. Okay, I didn't cover the ANOVA part. We will be doing the non-parametric version of ANOVA, but the parametric version, that is the ANOVA itself, was not covered by me. So we'll be looking at those parts. Just I will give an overview of them. Okay. So for the time being, I will be covering the Man-Whitney-U test. It is a non-parametric statistical tool or statistical test used to compare two independent groups. Okay, like think about it like a plan B. Okay, the plan B for the independent sample t-test. While a t-test compares the means of two groups, mention that the two independent groups. Okay, it requires the data to follow a normal bell curve distribution. But if the data is not normal, okay, then we are not able to apply the t-test. So what to do? Then we will use this Man-Whitney U test. So I have noted down this part that two independent groups are needed. In t-test, I have given an example that we want to know want to compare the blood pressure, average blood pressure of two groups, like a female group and a male group. Okay, but similarly, here we are doing for two independent groups. Note that the female group and the male group are two independent. There is no link in between those groups. Okay. Here the same kind of thing. This is the non-parametric version of independent t-test. Okay. The data are ordinal and or not normally distributed. The sample size is small. Assumption of the independent sample t-test are violated. I have already covered the assumption. What the assumption? Sorry. What are the assumptions of t-tests? I have already covered those parts, so I am referring to the link for the previous lecture. I'm not re-explaining that. So the assumptions of the t-test, mainly keep in mind that the most important assumption is the normal distribution. Here, the distribution of the data is not normal. Okay, this is the main and the most crucial assumption which is getting violated. So, what is the situation? Two independent samples, paired t-test is not suitable because the assumptions are getting violated. The data is skewed or not normal. Ordinal data, mean comparison is not possible. What we have done in t-test, we were comparing the mean or the mean difference. We are talking about the mean difference. But here, the data is ordinal, so we are not talking about the mean comparison or anything. Okay. The presence of outlier in t-test, we were not able to deal with the outlier. But here in non-parametric test, we can deal with the data where the outliers are present. So, is this slide clear to everyone? Or should I move?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So there are two examples that gender comparison. A researcher want to compare stress levels of male and female students using an ordinal stress scale. Like see that in parametric t-test, we are comparing the blood pressure, average blood pressure, which can be done like which was quantitative data, right? But here, the stress level, can you give some measure the how can you use the stress level and the BP level comparison? Can you give it? No, right? So you have the ordinal data here. You have some stress scale. It is the main point why we are using man-Whitney test. The data is ordinal and non-normal. Okay. So two independent groups plus ordinal data. So use we will be use the man-Whitney U test. This is the example one. And for the next example, teaching method, marks of students taught by online and offline methods are compared, but the data are highly skewed. Look at this thing. The online and offline, both are methods are independent here. In paired t-test, what we have done that suppose we are applying some teaching method and we were comparing the previous result and the post result. Okay, after applying the teaching method, but here the online teaching method and the offline teaching method both are independent. Okay, keep in mind, don't mix up those things. This online teaching method and offline teaching method both are considered to be independent. Okay. Assumption of man-Whitney test, sample are independent, observations are independent, data are at least ordinal, shape of the distribution should be similar for median comparison. In t-test, we were dealing with mean comparison or mean difference, but here we can deal with median comparison. Hope the examples are clear. I'm moving to the next slide. So, what is the generalized hypothesis? Two populations are identical, no difference in the distribution. Two populations are differ significantly. This is the null hypothesis. This is our alternative hypothesis, as you can see. So now we need the test statistic for U1. Look at this. This is N1. That is the sample size for group 1. This is the N2. That is the sample size for group 2. And this whole part is U1. This is not our test statistic. Our test statistic will be U, that is minimum of U1 and U2. But to calculate the minimum of U1 and U2, you need U1 and U2, right? So you first need this part. R1 is the rank sum of group 1. Sum of the ranks for group 1. R2 is the sum of the ranks for group 2. And we will be considering the U, which is the smaller of U1 and U2. So, what are the steps? What is the test procedure we need? First, we have already considered the hypothesis. Now, take what our next goal to combine all the data and rank them. Okay, take all the data points from both the groups and put them in a single list and order them first from smallest to largest. Okay, assign the rank 1 to the smallest, 2 to the next, and so on. To handle the tie cases, I have already discussed the tie case in previous lecture. You have to give the average rank. Okay. After combining all those data points and giving the rank to each of the points, then put the ranks back to their original groups, like group 1 and group 2, separate the ranks. The most important thing is to separating the ranks. Okay. Calculate the rank sum, that as you have already separated the ranks for group 1 and group 2, now you have R1 and R2. Rank sum for the group 1, rank sum for the group 2. And using those R1 and R2, you can calculate this part, that is U1, and using R2, you can calculate U2, right? Now select the smaller in between U1 and U2, that is U. For us, that is U. So next, we have the test statistic. Now you have to calculate the U and then get to our decision rule as usual. If the calculated part is less than equal to the tabulated part, then it is we have to reject the null hypothesis. If the calculated part is greater than our tabulated part, then we will be failing to reject the null hypothesis. Is this test clear to everyone? Any question, any doubt? So if I give you some numericals in assignment, will you be able to do that?
Okay, ma'am.
So hope this part is clear. So moving to the next test, that is sign test. Okay. So sign test is the most simple. Okay, it is the simplest non-parametric test available. It is often called a distribution test also because it makes no assumption about the shape of the data. It ignores the size of the difference, like we don't need the magnitude here in your data, and focuses entirely the direction. That is, we are focusing only to the sign, only to the direction or only to the sign, not the magnitude. Okay. Why to use this test? We have paired or matched observations, and it doesn't for every non-parametric test. Keep in mind that the normality assumption is getting violated. That's why we need the non-parametric test. Otherwise, parametric test was very good for us. Okay. So this is the common part for each and every test. Only the direction of change matters, not the magnitude, as I have already told. The sample size is small. Difference may be measured on an ordinal scale. So, what are the type of samples that paired? Like for paired cases in t-test, paired t-test actually, I have given an example that for students, we are comparing the marks after applying a teaching method, like before applying the teaching method and after applying the teaching method. We are comparing that mark. So there are paired cases, right? We have paired data here. Don't mix up the independent case and the paired case. Okay, for independent case, both of the groups are independent to each other. But here, both of the groups are not independent. They are affected by the teaching method. In my example, they are affected by the teaching method, right? So there is a paired case. And for the previous Van Whitney test, we were dealing with the independent, not the paired. Keep in mind. The scale of the sample is ordinal. The distribution free actually, no normality assumption. Data use signs of difference. Like I have already told, no magnitude is needed here, only the direction or the sign is needed. Hope this part is clear. So now the situation before and after studies that I have already told through my example. Paired observations are there. Only direction matters. Q data, that robust method it is. Presence of outliers for every non-parametric case as the normality assumption violates. Similarly, the presence of outliers is also there. Okay. For parametric case, it is not there, but in non-parametric case, presence of outlier is there. So there are two examples, that is training effect. Productivity of employees is measured before and after the training. Only improvement or decline matters. Right. Here no magnitude is needed. Only the direction is needed. Is it improving or is it declining? Right? The medical test similar. Actually, pain level of patients is recorded before and after the medication, but scores are ordinal. Hope the examples and the situation where we need the scientist is clear. Any question, anyone? Or should I move to the next slide? Assuming that each and every part is clear. So moving to the next slide.
Yes, ma'am, we can move.
Okay, fine. So now talking about the test procedure and decision rule. So what are the assumptions? Assumptions were paired data say if pairs are independent. Look, the pairs, each and every pair is independent. It is not that the after and before effect, the before and after effect, they are related. That the observation in each pair, those are related. But each of the pairs are independent. Like you have the data for student 1, student 2, up to student 10. The observation observed pair for student 1 is independent to the observed pair to student 2. And similarly, it is independent to student 3. But the observation in between the pair the observations in the pair are not independent. They are dependent. Hope this confusion is clear. Which data is independent and which are not independent. So difference can be assigned plus or minus. So what is our hypothesis? The median difference is equal to 0 for the null hypothesis. That is no effect, no change. Keep in mind in t-test we are dealing with mean differences, but in non-parametric test, in sign test, we are dealing with median differences, not the mean. H1, that is our alternative hypothesis, that is median difference is not equal to 0. That is, there is a significant change. So, what is our test statistic? Count the number of positive signs and count the number of negative signs. Ignore the zero differences. When there is no change, then we will assign the 0. Okay. But here we don't need to think about the 0 part. We will simply ignore that. Fine. Use the binomial distribution to test significance. We will be dealing with when I will show you the test statistic. Just a second. Can I attach it? Just a second. So the assumptions and the hypothesis, this part is clear, right? Any question? Any confusion in this hypothesis formulation?
No, ma'am.
Okay. So I'm going to the test procedure. What to do in this test? First, calculate the difference and assign the sign. For each of the pairs of data, subtract the second value from the first value. That is the after effect and the before effect. Second value is the after effect and the first value is the before effect. Okay. So subtract the after effect from the before effect. If the result is positive, assign a plus sign. Okay. If the result is negative, assign a minus sign. For tie cases, if the difference is exactly 0, we will ignore that. Count the sign. Count the total number of plus signs and count the total number of minus signs. Let the n be total number of non-zero signs. That is, n equal to number of plus signs plus number of negative signs, minus signs. Now, you have to identify the test statistics. Test statistics will be smaller in between two signs. Like you have n plus, that is number of positive signs, and you have n minus, that is the number of negative signs. You have to calculate the n, that is the minimum of n plus and n minus. Okay. Now you have to determine the p-value. What is the p-value here? P-value is we will be assigning that because we will be determining the p-value because the scientists assume the 50%, 50-50 chance of getting a plus value and getting a minus value. That is the median difference is 0 here, right? We are assuming the 50-50 chance for each of the cases in null hypothesis. Here, this part, like we have done this part, we have covered this part. Now we will be dealing with the binomial distribution part to test the significance. So, what will be that? We are aware of the PMF of binomial distribution, right? So here we know that we have assumed in null hypothesis that there is 50-50 chance for each of the cases. So the probability that the value of P here is 1 by 2, that is half. Okay. Is this part clear why the value of probability of success and probability of failure? Probability of success is considered to be the plus sign and probability of failure is considered to be the negative sign. Okay. Assigning the plus sign is probability of success and assigning the negative sign is the probability of failure. So the median difference is 0. That means P equal to Q equal to half here. Okay, if we think to the point of binomial distribution, is this part clear why the P and Q value is uh, assumed to be half? Any question?
No, ma'am.
Okay. So dealing to the binomial distribution, we will talk about the probability of sorry, the probability of x up to k can be any natural number, is equal to, please note it down, yeah, very bad handwriting, but I hope you can understand. Please note down this formula. So if the sample size is small, that is, here small means we are considering the n to be less than equal to 25. Use a binomial probability table, that is the tabulated value I am calling, to find the p-value for k and for appropriate k and n. And for large value, that is, if the n is greater than 25, then we need to do the normal approximation. I am not covering this part because I think this is out of your syllabus. So I am dealing with only the only the binomial case, not the Z4 case. Just I have given the overview that here is a Z4 case, that it is, I think, out of your syllabus. So now what is our decision? If the calculated p value is less than alpha, then we will reject the null hypothesis. If the calculated p value is greater than equal to alpha, then we will be failing to reject the null hypothesis. Okay, is this test procedure and decision rule, is this clear? Any question, any doubt?
No, ma'am, clear.
Okay. My screen is visible, right?
Visible.
Okay. So there is a comparison for scientists and peer t-test. So you can say that scientist is the non-parametric sibling of peer t-test. Okay. So here is the difference. Why it is. The data type for scientist is ordinal. For peer t-test, it is interval or ratio. Here, the normality assumption is not there, as I have already told, and it is required in t-test. Direction matters for the scientist. For paired t-test, we need the magnitude. The power is low here, obviously. For PRT test, it is high because we are dealing with the magnitude. The robustness is very high in sign test because we can deal with the outliers, but it is sensitive to the outliers. Hope this comparison clear. So moving to the next test, actually we will be covering all of the non-parametric tests in a single day. So it might happen that you feel uncomfortable or you feel that too much load, but we have to cover it today. So previous two tests are clear, right? No questions are there. If you have any questions, feel free to ask me. Obviously, otherwise you will not be able to do the assignment. I will be putting numericals in the assignment, so just feel free to ask if you have any question. For the decision rule part, it is same for each of the tests. No ambiguity should be there, but the test procedure a bit different for each cases. So giving you 2 minutes to just have a look for previous two tests, and we will be covering two more tests.
Hello, Sneha. As per my knowledge goes, the
Hmm.
scientist, uh, any data set you have, then that will be better to understand.
At present, I don't have
Uh,
data set, but I have an example. Like I put it in the assignment so that the students can do that part. So should I discuss it here? Uh,
yeah, because the when you are talking about the scientist, it is the plus minus.
yes, yes,
Okay, so we are often using the PRT test,
yes,
and you are suggesting that is we can use the sign test also in
yes,
case of the pre-post effect of therapy or counseling, etc., etc. You have
yes,
given example of the uh, training.
yes,
This is good, but at least if we have some data, we can generate the data that is possible if,
uh,
so that then people can easily understand.
oh,
Otherwise, we are prepared with the values. No? So when you are talking about the scientist,
yes.
students may not have understood. That is my opinion.
Okay, okay. So I will be dealing with an example,
Uh,
a numerical example. So yes, but this is not in this slide.
no,
Right.
no. For example, the doctor usually says, "How are you?"
Hmm.
And usually the patient says, "Okay, I am okay."
Hmm.
And doctor is following the different evaluation day. How are you? How are you? Maybe in the hospital. And
Yes.
patient says, "No, I am not well today." So
Hmm.
that is the negative sign.
Yes.
And I am okay, that is the plus sign.
Yes.
So how we can manage? Maybe the same individual is there in your case because it
Yes.
is paired. So
Yeah.
the same sample twice or thrice, just
Okay.
to-
I have
uh,
a data set. Okay. I'm just
hmm,
discussing this part. I have a data set.
okay.
So okay. So suppose we have a new sleep app. Okay. And a researcher wants to know if the new medication app helps people fall asleep faster or not. They measure the time to fall asleep in minutes. Okay, 10 people are giving the interview. So I have the data. So I'm giving you the data. I'm not giving the data. I'm just reading it from my data set, and you can note it down, students. For participant one, the sleeping time was 45 minutes before the medication. After the medication, it is 30 minutes. For patient 2, it was 20 minutes and it is now 22. For patient 3, it was 60 and after the medication, it was 40. For patient 4, it was 35 and after that, after the medication, it is 15. For patient 5, it was 30 and after the medication, it is also 30. For 6, it was 50 minutes and after the medication, it is 25 minutes. For patient 7, it was 40 minutes. After the medication, it is 42 minutes. For patient 8, it was 45 minutes. After the medication, it is 20 minutes. For ninth patient, it was 25 and after the medication, it is 10. For patient number 10, it was 55 minutes and after the medication, it is 30 minutes. So, is the data clear or anyone has noted down?
which is reducing, with comparison with
Uh,
the fast tense, because
Actually, for each of the cases, it is not reducing because for the second patient and the seventh patient, for each of the patients, the time is increasing. Okay.
okay. Mm,
Yes. That is the medication is not useful to them,
mm,
we can say. So we have the differences, but we don't need the magnitude. The exact
mm,
difference is not needed to us. So we have the sign. For second and the seventh patient, the sign is positive. And for the fifth patient, the sign is tight case, so we will discard it or ignore it. And for the other cases, the time is reducing. That is, the sign is negative. So what we have, what our initial n was 10. Okay. But as I have ignored the non-difference case, the tight case, so our at present our n is 9. So n plus, that is number of positive sign, is 2 here and the number of negative signs are 7. So the test statistics k is smaller of 2, smaller of 2 is 2, right? Like n1 is n plus is 2, n minus is 7. So we are considering the minimum of n plus and n minus. So that is 2 here. So next we will be going to the binomial approximation. So the binomial approximation that just a second. I think the formula was there. Has anyone noted down the formula? The binomial?
Yes, ma'am.
Okay, okay. Then it will be fine. Just put 2 instead of k. In the place of k, you have to put 2. Okay. Then we will be calculating the p-value. If we put 2 there, then the p-value will be 0.0899. Okay. But what is our alpha? We are dealing with the 5% case. So our alpha will be 0.05. But our p-value is 0.0899. So our p-value is greater than the alpha. So we are failing to reject the null hypothesis. Is this example clear? Is this example relevant, sir? Is it understandable? Like using the present data?
yeah, this is now clear.
Okay.
Mm.
For the students, is it clear? Any part
Yes,
to
ma'am.
re-explain? Okay. So should I move to the next test?
Yeah.
Okay. So this is Wilcoxon sign rank test. So this is a sibling of sign test. Okay. It is more powerful sibling of the sign test. The Wilcoxon rank test is a non-parametric test used to compare two related samples, match pairs, or repeated measures of a single sample. Actually, these are kind of same as I am talking about the siblings. They are same, but while in sign test, we only look whether a change is positive or negative. But in Wilcoxon sign rank test, we will be dealing with the magnitude also. We are dealing with the sign and the magnitude. Both are under our consideration. So this is our case, that is paired or matched samples. The dataset is not following normal distribution as previous. It is more powerful than sign test, as I have already told. It is dealing with the sign and the magnitude also. That's why it is more powerful. Assumption of t-test is violated as previous. It it improves upon sign test by the rank differences. Type of data is paired and ordinal, and it is distribution free, and we have direction plus magnitude of distribution. Magnitude of difference. So what is the situation? Before and after cases, that is the paired data, normality assumption is violated. Need more power, that is more, it is better than the sign test and the ordinal measurement, that is rank based. So the examples are quite similar. Okay, the only difference is in the test procedure. That's not, we are not dealing with only the sign, we are also dealing with the magnitude and the sign also. Okay. So I'm not giving the same example again, you just have a look. So our assumptions are exactly similar. The new assumption is distribution of differences is symmetrical. That is median difference is zero, as we in parametric test we deal with the mean, but here we are dealing with median, and the median difference is not equal to zero. So what is our test statistic? Compute the DI. DI is the difference between the ranks. Like in previous example, the previous time of the sleeping, that is medication, previous result and post result, right? We are dealing with the differences, that is DI. Assign the ordinal signs to the rank. W plus, that is the sum of the positive rank, and W minus, sum of the negative rank. As previous, we will be dealing with the minimum of W plus and W minus. So I am explaining the test procedure by example. Like for every pair, subtract the before score and the after score. Like for example, for the sleeping example, the first person had, I think, 30, 45 and 30. So we will be dealing with the sign negative, right? For before it was 45. Uh, for the before case it was 45, right? I forgot the example. Has anyone noted down what was the figure? Suppose it is 45. I am thinking that it is 45, and the after it is 30. So the difference is plus 15 here, right? For next, it was plus 2 or something. I plus 2 or minus 2, something it was there. Just the main thing is to calculate the difference and not only focus on the sign but also focus on the magnitude. Rank the absolute differences. Like after getting the differences, ignore the signs for the initial case. Okay. At initial state, ignore the sign. Rank all the differences from smallest to large. If the difference is 0, discard the pair as I have already done in the previous example. If the difference is 0, we will be decreasing the sample size there. Okay. If tie cases there, then give the average rank. So the tie case is also, it can be also there, but in most of the cases, we just deal with non-tied cases. Tie case can be there. It can be in our example. Okay. So then after ordering, after dealing with the ranks, reattach the sign. Give the rank back to their original sign. If the difference is negative, then the rank itself become negative. If the difference is positive, then the rank stays positive. Then sum of all the positive ranks that is considered to be W plus here and sum of all of the negative ranks that is considered to be W minus here. Then our test statistic comes which is W, which is the minimum of W plus and W minus. Now compare the W with the critical value. Critical value will be tabulated value. Just like the man-Whitney test, we reject the null hypothesis if W is less than or equal to the critical value. Like, yes. For this, all the steps are mentioned here in one line. What I have explained in details, you can just have a look. The test scenario, the difference between Wilcoxon sign rank test and sign test and the decision rule. Is this are the three parts clear to everyone or any part to re-explain? If someone asks you that what is the main difference between sign test and Wilcoxon sign rank test, then what will be your answer? What is the basic difference between these two? Anyone? I mentioned it again and again.
Ma'am, repeat the question, please.
What is the difference between sign test and Wilcoxon sign rank test? Like the previous test and this test, both are similar kind of, right? There is a possibility of getting confused. What is the difference? Like why we are dealing with the Wilcoxon sign rank test? Why not sign test? From the beginning of discussing this test, I was uh, explaining that again and again why we need this. So anyone? For this case, we are dealing with sign and magnitude. For the previous case, we were dealing with only the sign, not the magnitude. I have mentioned it, right?
Yes, ma'am. Yes, ma'am.
So if someone asks you, can you answer it now?
That is the absolute rank by the absolute size or the value and the sign rank test and plus minus. And in that case, only the direction. Yes.
In sign test, only the direction matters, but in this test, Wilcoxon sign rank test, the direction and the magnitude both are our under our consideration. Okay,
So
is this
how do
clear
they
to everyone?
interpret?
Yes, I have given.
How do they interpret the data, the result?
Yes, sir, I have given the decision rule, right?
Uh,
I have told the decision rule. Like if the it is similar to the man-Whitney test. The decision rule is similar to the man-Whitney test. That is, if the W, that is the test statistic, calculated test statistic is less than or equal to the critical value, then we will be rejecting the null hypothesis. Right?
mm. Okay, students, now is it clear to you? Please give feedback to madam.
Yes, ma'am.
Yes, ma'am.
Okay.
Okay. Okay. So the previous example is clear and this test is also clear. I hope that. So moving to the last test. Oh, sorry. There is a difference. There is a difference between Wilcoxon sign rank test and the t-test. Why the pair t-test is not appropriate and why we need the Wilcoxon sign rank test. So, similar case, actually, the ordinal data and the non-normal data type. Normality is not there, and this is rank based, and this was pair t-test was mean based. That is, we were dealing with the mean difference. This is moderate, and as we have the parametric case and the normality assumption is there, so the pair t-test is much high. Like we have the higher power. Okay, the robustness is high here because we can deal with the outliers, but for pair t-test it is sensitive because outliers can't be dealt with it. Okay, so now the last test. So in the assignment, I will be giving numericals for each of the tests. Okay, and after explaining this test and the decision rule, I hope that you will be able to do each of the numericals. And if you have any kind of doubt, please feel free to ask me. And you can contact me later if you have any doubt or in doubt regarding the assignment because I know these tests are a bit tricky and we are dealing this test simultaneously in a day. So it might happen that you students might get confused with the test. Okay, so it's fine. So this is our last test. In parametric case, we deal with ANOVA, but ANOVA was not in your syllabus. That's why we were confined with the t-test only, not the ANOVA case. But for Kruskal-Wallis is the non-parametric sibling of ANOVA. Okay, so here we compare three or more independent groups. In Man-Whitney test, we were dealing with the independent groups, but there were only two groups. Okay, there was only two groups in Man-Whitney U test, but in Kruskal-Wallis, we can have three or more groups. It is essentially non-parametric version of one-way ANOVA, just as Man-Whitney U test is a comparing of two groups, Kruskal-Wallis, when we have three or four or more groups. Okay, and data is obviously not well behaved. Like it might happen there are outliers as usual. For previous cases, it can happen that there we have to deal with outliers, and here also we can deal with the outliers. The non-normal assumption is also there. This part, not normal and ordinal data. The sample size is small and unequal. So, what is the data? Is my screen visible or not? Like,
Yes, ma'am,
is it
visible.
visible? Visible?
Yes, ma'am.
Okay, fine. So what are the situations when three or more independent samples are there? Man-Whitney test is not appropriate for that because we dealt with two groups when we use Man-Whitney. Okay, non-normal data is there. If for the normal cases, we will be dealing with ANOVA. For non-normal cases, we will be dealing with Kruskal-Wallis. This is ordinal scaled data, and the presence of outlier is there. So, there are some examples. Two examples are there. Student marks are compared across three teaching methods. That is online, offline, and hybrid. Like in Manwitney test, I have given the same example, I think. Yes, the marks of students taught by online and offline methods. But Note that there are two groups only, online and offline. But here in Kruskal Wallis, we have three methods and three of them are independent to each other. Online, offline and hybrid. Okay, we have three different methods. The medical study pain scores of patients receiving three different treatments are compared. Like, are you getting the difference between the Man-Whitney and the Kruskal Wallis through the examples? Please respond. When do we use Man-Whitney and when we should use Kruskal Wallis? Is this difference clear to everyone?
Ma'am, repeat once.
More than two groups, no? In case of the
Yes,
Kruskal Wallis.
yes. For Man-Whitney, look, I have given the same example so that you can differentiate between both of the tests. Okay. For Man-Whitney, student marks are compared across two groups only. That is the online study method and the offline study method. What is it? Yes, this one. Student marks were compared for online study method and the offline study method. Okay, two independent groups. But for Pushkar Wallis, we have three groups. That is online study method, offline study method, and hybrid study method. And three of them are independent to each other. No relation in between three of these groups. Is this clear now?
Yes, ma'am.
Okay. Okay. So what are the assumptions? That samples are independent, observations are independent, data are at least ordinal, population distribution has similar shape. So now our hypothesis, all populations are identical. That is no difference among group medians. Like in, what was our hypothesis? Two populations are identical. No difference in the distribution for two of the populations. And here for Pushkal Wallis, where the Nara hypothesis is exactly same. But there we were dealing with only two groups. Here we can deal with three or more groups. Okay. So our null hypothesis is all population are identical and the alternative is at least one of the population differs significantly. So what is our test statistic? This is our test statistic. Please note down the formula where n is the total number of observations. That is total number of observations means the all sum of the observations from group 1, group 2, group 3 and up to group I. Whatever group I have, suppose I have I groups, then total number of observations across all the groups. Okay. Ri is the sum of rank of ith group. Like till now we were dealing with ranks. So I hope the uh, concept of ranking is now clear. So I'm not re-explaining the ranking part. So Ri is the sum of ranks of the ith group. Okay, and Ni is the size of the ith group, right? Like for the group 1, Ri is the sum of the ranks of group 1 and Ni is the sample size of the sample size of group 1. But the capital N is the sum of all the observations, that is N1 plus N2 plus up to suppose Nk. Okay. So what are the steps? Combine as previous, it is not new to you people because we have already discussed all the tests till now. So combine all the groups and rank the combined data, find the rank sum. After combining the data, you have to separate it for all the groups and find the rank sum for each of the groups. Substitute the value here. You have to substitute Ri, Ni, N, and whatever we have. And yes, this is the formula. Find the degrees of freedom, that is K minus 1. K is the number of groups. Suppose I have 10 groups, then the degrees of freedom will be 9. Compare the calculated age, that is this calculated test statistics, with the chi-square table, that is this is the tabulated value. If the calculated value is greater than the tabulated value, then reject null hypothesis. If the calculated value is less than the tabulated value, then we will fail to reject the null hypothesis. So this is our procedure, our statistics, and our decision rule. So this is the
It indicates, Neha, that means when we want to compare
hmm,
maybe the three groups, okay,
yes,
suppose the three groups are significantly different,
yes,
therefore we can give importance on the group median rather than the
yes,
group mean, correct?
yes, because
Because I
we
have
can't
seen
deal
many
with
research papers where they are
hmm,
using Kruskal-Wallis test and they are comparing the result with respect to the mean. I think mean is not the correct answer. I have
no,
written
no,
the group median is important
yes, median
rather
is
than the
important
group
because
mean. In case of the ANOVA, we can use the group mean, but in
yes,
case of the Kruskal-Wallis, we have to follow the group median.
median, yes.
But I have seen many research papers, published research papers, and some papers have been sent to me also. I have suggested that is, please you use the group median rather than the group mean. Hmm.
Actually, for the mean cases, if we can deal with the mean, then what is the need of Kruskal value? Because mean
Hmm.
is sensitive, mean is sensitive to the outliers, right?
Yeah,
So we cannot deal with the mean here. The median is not that much sensitive to the outliers. That's why we
correct.
need to deal with the median case. Okay.
Hmm.
So now,
Yeah, in case of the ANOVA, we can use the 2 by 2, etc. ANOVA,
yes,
we can do. But in case of the Kruskal-Wallis, we cannot do.
actually there is a post hoc test. I will be discussing just I will give an overview of that. Like
Acha.
uh, in ANOVA case, that you have told the 2 by 2 case, we can
Hmm.
deal with Kruskal-Wallis that also. Like if the Kruskal-Wallis result is significant, that is the p-value is less than equal to 0.05, we must
Hmm.
perform a post hoc test. That is the multiple man-Whitney test. Like it might happen at least one population is different, uh, for which the whole population we have to accept the alternative hypothesis. But we are not aware of that for which population the null hypothesis is getting rejected, right? So we have to deal with the post hoc test, that is the man-Whitney test. Like we have to compare all of the paired, like for group 1 and group 2, like we have suppose we have three groups, so we have to deal with 3 choose 2, group 1 and group 2, group 1 and group 3, and then group 2 and group 3, we have to test for each of the pairs, and after that we have some conclusion for which group the alternative hypothesis is getting accepted. Okay.
No, for example, I am interested that is the effect of gender and its interaction with the intelligence, okay, IQ,
Okay.
on the
Okay.
academic achievement.
Okay.
Okay.
Hmm.
Then it will be the 2 by 2
Hmm.
or 2 by 3 like that.
Okay.
What we can do in case of the factorial design, in case of the ANOVA, but
Hmm.
this is not possible in the Kruskal-Wallis. I think
Uh,
so. I do not know.
Actually, I also have to think about this because for a
Hmm.
square table, we can do like 2 into 2, 3 into 3, we can do Kruskal balance. But can we do it for 2 into 3 or 3 into 4? I have to think about this.
Uh,
Yes.
this is, I think, very important because in our case, we are following the factorial design type of model.
Okay.
Factorial design in experimental research, particularly for the PhD.
Hmm.
They want to control and they have to find out the interaction effect also.
Okay.
Therefore, that may not be possible, I think, in Kushkalwalish. Kushkalwalish can tell only the group difference based upon the rank data.
Yes.
Mhm.
Then we have to search about it. It might happen. Like I have not seen this kind of example till now. So that's why it might
Okay,
happen. There can be or there cannot be also. But I will be checking this part.
okay, okay.
Yes. So this is our last slide. Oh, I have explained it, right? This ANOVA and Pushkal difference. Yes, I have explained it. And the is the post hoc part is clear to the students? Like how when do we need it? Like it is out of your syllabus, so I am not dealing with it with an in great details, but just for an overview, is this part clear or should I repeat it?
Okay, ma'am.
Okay, then fine. So this is the summarized slide. When do we need what type of test? When it is chi-square, when do we need it? When do we have categorical data? Association of ranks, we need Spearman rank correlation. For two independent group tests, to test the median actually, for two independent groups, we need Mann-Whitney. Paired sample case, we need sign or Wilcoxon rank test. Keeping in mind for sign test only we have the direction. For Wilcoxon we have the direction and the magnitude simultaneously. So as per the need you have to choose the test. When you have to use sign test and when you have to use the Wilcoxon rank test, you have to choose as per your need. For the three or more independent group, we have Pushkal-Wallis test. So this is the summarized slide. When you can see this kind of data, you have to use this kind of tests. Okay. Is there any doubt?
So students, can you tell me that is if
Anything
I
to
want
ask?
to do the pre-post intervention, then which statistics we can follow? This looking at the final comparison chart. I want to find out the pre-post effect of counseling on some behavior, whatever might be. Then which will be appropriate? Please tell. So this is basically the paired sample. So we can use the Shine and or Wilcoxon sign rank test.
The
Am I correct,
example of
Neha?
medication. Yes, the I have very much surprised that the example of medication is already I have given, right? Instead of
Hmm.
asking this question, the students are not able to answer. I'm very much surprised.
No, no, they will study thoroughly.
Yeah. So, okay, this is up to you and
Okay.
nothing to cover more.
So students, do you have any question? Jolly, Suma,
No, sir.
Sir.
you have understood. Okay.
Okay.
Osmita, do you want to add something?
No, sir.
Okay.
Just would like to request the students to please complete the assignments. A lot of assignments are pending. So please,
This
as
is a
and when Sneha ma'am
very
is
serious issue.
Yes, as and when Sneha ma'am is giving the assignments while the material is fresh in your minds, please go through the assignments.
Okay, thank you, Sneha.
Thank you, sir.
Today you have finished very nicely.
Thank
I
you, sir.
hope the students will follow the YouTube, and if they have any question, they will ask us.
Yes, sure, sir.
Hmm. So may I close the session?
Thank you, sir. Thank you, ma'am. Good night.
Thank
Thank
you,
Good
you.
night.
sir.
Thank you,
Thank you,
everyone.
ma'am.
Thank you, sir. Good night.
Good night.
Make me host. Sneha, you make me host.